European light bulb. In Europe, the standard voltage in homes is 220 volts instead of the 120 volts used in the United States. Therefore, a 100 watt European bulb would be intended for use with a 220 volt potential difference. Part A. If you bring a 100 watt European bulb to the United States, what should be its US power rating? And part B. How much current will the 100 watt European bulb draw in normal use in the United States? Okay, so we're actually talking about plugging it into an AC outlet here. So I want to basically clarify that we have a purely resistive load. And if you have a purely resistive load, the formulation for the power in AC circuits and DC circuits is the same. So when we say that we have a 220 volt potential difference, in AC circuits what we are referring to is the time averaged power, which is equal to the root mean square voltage multiplied by the root mean square current, which is equal to root mean square voltage squared divided by resistance R. Now the power in European Union is 100 watts, which is equal to 220 squared divided by R, and the power in US is going to be 120 squared divided by R, because we have 120 volts used in the United States. So if you take the ratio, the power in EU divided by the power in US is 100 divided by the power in US. That's the ratio of 220 to 120 parentheses squared. Okay, so this tells us that the power rating in US should be PUS is 100 times 120 squared divided by 220 squared. So we find that the power rating in US is going to be 29.8 watts. Now in part B, the average power, P average, is Vrms times IRMS. So we have the RMS current equal to the average power divided by Vrms, which is 29.8 watts divided by 120 volts. So we can see that the current it will draw is IRMS, which is 0.248 amps. So that's the current it will draw. Now, we're going to talk about AC circuits much later, but we should note here that in AC circuits, the average power is Vrms times IRMS times cosine phi, which is the power factor, and this phi is equal to 0 degrees for a purely resistive load. And the definition of root mean square and current and voltage is maximum current divided by square root 2 and maximum voltage divided by square root 2, as we will show when we go through the discussion in AC circuits. So this is behaving just like a DC power. P is equal to V times I. But in reality, when we talk about outlets, we should basically know that we're talking about AC circuits. In this case, we have a purely resistive load that is being plugged into an AC outlet. Therefore, the formalism looks quite the same for AC and DC circuits.